All right, hello Algebra 1 honors. Today we're going to look at section 1.5, and what it talks about is rewriting equations and formulas. And you will also hear this referred to as literal equations, where there's not so many numbers, there's more letters, and you're asked to solve for specific variables. Well, I'd like to start with an example that you might be familiar with. And that is F equals 9/5 C plus 32. Do you know where this formula comes from? Well, yeah, it's a temperature formula. The way it's set up right now, it's set up so that if you know a Celsius temperature, you can substitute that in, simplify it, and it will result in a Fahrenheit temperature. But you don't always see the formula written this way. Oftentimes you'll see it written the other way for when you have Fahrenheit and you want to convert it to Celsius. So this is kind of helpful to be able to learn how to rewrite this. So our instructions are to rewrite to solve for Celsius. Well, what we do is we focus on what we're trying to solve for, and we just want to undo the operations that are being done next to the variable we're trying to get by itself. And often what we'll do is we'll do kind of the inverse or backwards order of operations. For example, we could get rid of this plus 32 first, then undo the multiplying by 9/5. Truth be told, you could do anything you wanted as long as you remember to do properties of equality and distribute if you need to. But I think probably the most straightforward way to solve this is to go ahead and subtract the 32 over. But what you'll find out oftentimes with rewriting equations and formulas is that things don't really simplify. So you just end up writing F minus 32 equals 9/5 C. And then to undo multiplying by 9/5, I suppose you could divide by 9/5, but I don't like that one bit. I would rather you multiply by the reciprocal to undo it. But what's interesting is when you multiply by the reciprocal to undo it, you're going to have to multiply this entire side by 5/9. You're going to have to distribute it. Now, oftentimes you'll see the formula written, so the 5s cancel, the 9s cancel. Oftentimes you'll see the formula written just like this, with the 5/9 outside of a parentheses minus 32. That's the most common way that you see it. And I like that answer. That's a good answer. But I would also, the math teacher in me wants you to go ahead and simplify it and distribute the 5/9. So let's try that out as well. You'll get 5/9 F minus, and then when you multiply fractions with whole numbers, you can think of it as being, the whole number as being over 1. And you're just going to multiply straight across. So that's going to be -160 over 9 equals C. So either one of these answers is fine. We've gotten C by itself. That's the important thing. All right. Well, oh, and also I guess you could write this as a mixed number if you'd like. But I prefer the improper fraction. All right, let's try another one. Sometimes they're just strictly math problems. So for example, we're going to solve for y. And we've got 4x minus 7y equals 12. We're going to find out that solving for y is a pretty valuable thing when we get into graphing. And also, when we solve systems of equations, a lot of times we have to solve for a specific variable. So I like to put a dot above what I'm trying to solve for. And again, I'm just going to undo things. Well, think of this 4x as one term. And I like to think of this as 4x plus a negative 7y. I could undo this -7, but I think I'd rather undo the 4x first by subtracting a 4x. Excuse me. So we had negative 7y equals, and you can write it as 12 minus 4x. My goodness, tickle in my throat. You could write it 12 minus 4x. Oh, get a drink of water here real quick. Goodness gracious. Woo! Let's see. I think I'm better. You could write it as 12 minus 4x, or as we're going to learn to do later, you can write it in as minus 4x plus 12 to be in standard form. And then finally, to undo that negative 7 is multiplying with y, so you got to divide by negative 7. But here's what I want you to do. I want you to distribute your division. Distribute it to both terms. And then we get y equals positive 4/7 x minus 12 over 7. And y is by itself. And later on, you'll find out that the 4/7, if you're graphing, would be slope, and the negative 12 over 7 would be your y-intercept. Okay, let's try another one. Practice is really important in this section. There's lots of kind of different sort of things that can happen. And one of those different kind of things is when you have 3w plus 4wp equals a. And this is a formula for something. I can't remember what it is right off. But what's tricky about this is we're asked to solve for w, but we have w in two different places. Now, there's lots of things you could try, and I encourage you to pause the video and try some things. But one of the best ways I've learned to solve for w when w is in two different spots is to do distribution in reverse. Reverse distribution. Now, if you look in a book, they're just going to say you're doing the distributive property, but it's backwards of how you're used to doing it. So when you have w in two different terms like this, you can bring w out to the front of a set of parentheses and then write what would be left over if you undid the distribution of w. So do you agree that if I was to distribute this back, I would get that back? That's kind of a way to check yourself if you did it right. Now, why did we do that? Well, now instead of having one or two w's to worry about, I just have the one w. And I'm going to divide that whole 3 plus 4p to both sides, division property of equality. And I get w is equal to a over 3 plus 4p. I could put the parentheses around there, but it turns out big fraction bar like that acts like a grouping symbol. So we're good. Kind of different, huh? Reverse distribution. Do that whenever you've got more than one variable that you need to get, and you want to rewrite it as one. Okay, well, I think that's where we'll stop for the day. Page 40. 3 through 16 will get you some practice just on these types of problems, but there's actually a full assignment that's in Canvas. All right, well, thank you so much. Have a great day.